Hi everyone, my name is Thomas Kim. Today is May 23rd, 2019. This is my 17th episode about the future of C++ programming, C++ 2A standard. I learned C language and C++ over 30 years ago. My first book on C language is A Book on C by Ira Pohl. This book. This is my first C book, and I read this book about 3 times when I first learned C++ language. Before I began to learn C language, I was already proficient with BASIC. I made simple games using BASIC, and I could completely understand how to use array, loop, and subroutine or function before I began to learn C language. So when I first began to read C language using a book on C, I taught C language by myself. I also taught BASIC by myself. I read a book on C. I read a book on C 2 or 3 times in 3 or 4 months. So I read this book several times in very short period of time because I understood most concept of programming, and through this book I learned about the C language type, the concept of a compile, the concept of preprocessing, and also the concept of pointer, the concept of struct. All these things I learned through this book. So when I first read this book, I was very excited about C language, and so I read this book almost every day, all day long, for 3 or 4 months. But there are some points that I could not understand in this book. At that time, I could not understand Tower of Hanoi algorithm described in this book, and also I could not understand the Polish notation calculator detailed in this book. Even though I read 2 or 3 times or even more, I could not understand Tower of Hanoi and the Polish notation calculator detailed in this book. I read several times but failed, then I skipped. But I committed these algorithms that I should learn these things sometime in future, so I committed it to my memory. One day, about 2 or 3 years ago, I was doing internet shopping and came across these Tower of Hanoi toys, and I purchased one of these Tower of Hanoi toy. Then I tried it once again in this video. I received the Tower of Hanoi game this day, May 18, 2018. When I received the Tower of Hanoi toy, I played with it about 10 to 30 minutes. Then I could completely figure out how to make Tower of Hanoi algorithm. So this day, May 18th, I filmed about complete Tower of Hanoi game in C++ language. Also, I purchased Introduction to Automata Theory, Language and Computation, 3rd edition, written by John E. Hopcroft and Jeffrey D. Ullman. These authors are very famous computer scientists, and I read this book 2 or 3 times, but I could not understand at all. You can read more about this book from this link. Even though I tried to read several times, twice or 3 times I think I read from cover to cover, I could not completely understand theory of automata and computation theory. As time goes on, I thought I need to build library for set operation, so I implemented a set operation extension talkplayfun.com. From this site, you can find I implemented the complete set operations, all algorithms for my own use. Then I built a lot of set algorithms, set operations. Then I tried reading this book again. Then everything seems to be very simple and clear. After implementing set operations in C++, reading this book again, I could completely understand and implemented quite a lot of algorithm in this book rather easily. So one of such algorithm I can show you from this episode of video. In this series of video, I implemented some of the algorithms, but actually I think I completely understand it now. So my point is something like this. Do not despair. Don't get bogged down, but commit it to your memory. Some of the algorithms, some of the theory you may not understand when you read the book for the first time or when you learn something for the first time. Some of the algorithms of some of the theory you may not completely understand. In such case, don't despair, don't get bogged down, but commit it to your memory. And someday you will come back to the same problem. And as you gain more experience and more expertise, then try that problem again. Then you will completely understand it later. In this episode, we will learn about sequential quick sort and some C++ optimization technique using std move and std make move iterator. I will explain the theory behind and I will show you how to implement it in C++, modern C++ completely. It might be a little bit challenging for you. But as I said, don't despair, don't get bogged down, but commit it to your memory and come back to it again later. Quicksort algorithm. Suppose we are given a set of elements like this. We create a function std vector int quicksort. We create a function, then std vector int, then container. For example, we are given function like this. Okay, we select the first element as pivot. So we create a result set std vector int result. Okay, then from this set we select the first element from this container. Then we can initialize like this front. Okay, so in this case result has only one element, 5. Initially it has one element. Then we remove from this container, we remove the first element. We can remove like this, container, erase the first element. We can remove like this, begin. Okay, remove the first element from the container. Then the container will have something like this. Then container will have, because we removed the first element, we have elements like this. Okay, this is the result. From this set, container set, we use partition. We make partition like this, auto itr std partition. We partition this container, begin, container, end, and we have to provide predicates here like this. The first element of result will be, I say, pivot will be result begin. Okay, this is capture clause pivot. Okay, then we take elements auto, or we can say constant auto reference e. We provide here predicates like this: return e less than pivot. Okay, then we close the partition algorithm like this. It can be a little bit complex, looks complex, but I will cut it. Then I will create like this: auto predicate. I will create a closure, lambda closure like this. Then instead of doing this, we can provide predicate. Okay. At this stage, this container will be partitioned like this. The container will be partitioned as below. Any element less than 5 will be set here. So less than 5 is 3. From this state, less than 5, then 4, then 1, then 2, then we have 9, 8, 10, or 7. Okay, it will be partitioned like this. Here, this ITR iterator will point to this element. ITR, this iterator will point to this element. Okay, so this is lower set, this is upper set. From this container partitioned this way, we can form like this: auto lower part std vector int. This is begin, container begin, this element container begin is pointing to this container begin, and container end will point this element. So I will make more room like this. Then this lower part will contain container begin from this element before it ITR. Then auto higher part we can build std vector int. Then from ITR to container end. Okay, container end. At this point, lower part contains element like this, and higher part contains these elements. Okay, like this. At this point, auto, we use this algorithm again, quicksort algorithm again, then sorted lower part. We call this function recursively quicksort. Then we pass this lower part, we sort lower part like this, auto sorted higher part. Then we call this function again. Now we pass higher part. Okay. At this point, sorted lower part will be sorted. If we sort this part, then it becomes 1, 2, 3, 4. Okay. Then sorted higher part will become 7. We missed 6 here. We missed 6 here. So I will put it 6 here. I can put 6 anywhere. I will put 6 like this. Or it can be, because this is 10, 6. I have to fix like this. Then this is 6. Then at this point it will be sorted. This higher part will be sorted through this recursion. Then it will be like this: 6, 7, 8, 9, 10. Okay. Now at this point, this is result initially. Okay. Initially we have result like this. Then this 5, this is iterator beginning with this. We can do like this. Result, insert. We insert. This points to result begin. Okay. Result begin will point to here. From here, result begin. To this current set, we insert sorted lower part before begin. I copy this, copy, paste, begin. I copy this once again, paste, end. I will make it line break here like this. At this point, result will be like this. 5 is here. Initially it was 5. We inserted this set before begin, so it was pointing to begin. If we insert it, then it becomes like this. Okay. Then at this point, result, insert. This points to last element now. Sorry, I made a mistake here. It points to after this element. Okay. After this element, I made a mistake here. So here it points to result and will point to here. Okay, result point will be point here. Result and here we insert this type, this part. Begin. Then I copy this part once again. It should be end. I will rearrange it. Then from this set, we inserted this element. This is the last element. Here, begin is the last element. We insert after the last element. After the last element. Okay, and always points to after the last element. After the last element. Okay, then if we insert it, here it means it insert before the last element. So it becomes like this. So this is final result. Okay, so we can return result. Then we implemented our quicksort algorithm. If you don't understand it, please watch this video carefully again. Also note that I made a mistake here. I have to fix like this, or I can say like this, front. Okay, I have to fix like this. This is one of the most typical implementation of quicksort. But now let's think about optimization. First, this container is vector container. Removing elements at the beginning like this is inefficient. Removing first element from the vector or STD vector is inefficient. So we can make efficient like this. I will copy this part of code. I will copy and paste it here. Okay. I say quicksort better algorithm. I changed the title like this. Now let's think about this. Instead of taking the first element, in this case 5, we can take last element. Okay, say back. We can take the last element, then it becomes 6 like this. Okay, we modified this part. Then here we can implement like this. This is removing last element from vector is very efficient. So we can modify like this. Instead, because we inserted last element here, result set, we can pop off like this, pop back. We remove the last element, then it becomes like this. From here, I copy once again here. Okay, since we remove the last element, it now becomes like this. Okay, and I don't make any changes. Now here, it should be 5. Okay, 5, and it should be 5. No. It should be 7. 5 is somewhere here, like this, because we removed 6. Okay, now at this stage it becomes 1, 2, 3, 5 here. It becomes like this, and it is at this point it should become 5 here. Here it should be like this. Okay, because 6 is in pivot. Value 6 is in pivot. Now at this point it should be, this is not 5, this is 6, then it should be like this, 6. Then the final result is the same. Okay, so we used, in this approach, we use the property of STD vector. We can remove the last element efficiently. Okay, we used this property, and I will copy once again. This is not also very efficient. I will explain. I will copy once again. At this point, I will say quicksort much better algorithm. Now in this case, let's think about this. After this point, we partitioned this container class, and from this point on, we don't need this container. We don't need to keep this container. Okay, we don't need this container. So instead of doing this, we can move the elements. For example, it is, let's change it into like this, std string, or we can say banana, cherry, I say dango, cherry, and apple. Then A, B, C, D, E, echo. Okay, so we are sorting this element. Now it is a string. Okay, string container. So it should be string, and it should also be string. Okay, in such case, moving element itself is expensive. Here, moving element is expensive. So instead of doing this, we can optimize moving element like this. std make move iterator. I copy this part, copy, and I paste it once again. Then it should be itr. We can fix like this. Okay, so here it should be std string. I will copy all. I will also replace here. I should also replace it. Now let's see. Okay, I replaced all. So copying string is expensive. Instead, we can use std make move iterator to move elements from one container to another. So we used here move iterator. Okay, also here we can take advantage of std move iterator like this. I will copy this part. I copied here and I paste it here. I paste this part, then I paste it. It should be end. Okay, we modified once again like this. We can do like this. So now in this part, let's think about in this part too. So this lower part is temporary. Lower part is temporary object. Okay, also higher part is temporary object. So we can use move, std move. Okay, so I change like this. Here also std move. We can modify it like this. Then everything. Also here again in this part, this sorted lower part is also temporary. These are temporary, so we can move elements like this. std make move iterator and paste it here. Also here std make move iterator. So we can modify like this. What is this? Okay, I made here. I will fix like this. Now in this part we can also use make move iterator. I will copy this. I copied, pasted like this, and also I pasted and modify like this. So this is the most optimized way. In case of the element, the container element is class type or container type like string, we can take advantage of std make move iterator to move elements from one container to another container. Also, because we use these temporaries and they are not used anymore after this part they are not used anymore, so we can just move elements like this. Also here we used std move iterator in both cases. This way we can highly optimize our code. I will copy this code once again from here and copied, pasted sequential quick sort. I change like this name and I will remove some part. I don't need it. I will turn it into template, type name element type like this. Then I copy this and paste it here. Also I paste it here. Also I paste it here. And let's see. I will also paste it here and paste it here. Now we turned it into template. I think this looks very long and ugly, so I will make it alias, template alias, template function template alias. I will make a template function alias like this. It should be auto. Okay. Move iterator like this. This is template function template. I have to make like this. DECL type. We can use this container begin. Okay. Then we created, let's see, this part. Okay. Now with this, we can copy this and we can make it clean like this. Okay. We can make it much cleaner. Also, we can make it clean. Paste. Paste. And here we can also make it clean. And here too. Here too. Now I will remove some part. I will delete this part now. I removed, and I also remove this part, and I will remove this part. So in this case, we actually don't need to do this. This is temporary. Instead of doing this, we can simply copy like this. Cut, and we don't need it. Just like this. Okay? And also this part, we don't need this, so I will just copy like this. Copy and paste it. Because we don't need this. These are for temporary. I will remove, modify like this. Okay. I also introduce container type here. using container t std vector element type. Okay, with this I can make it shorter like this. And here we also don't need this. We can make it shorter like this. So I will fix like this. Here also and I will make some arrange like this. Okay, I don't think we need this. Also here move and like this. I fixed like this, and we don't need this part. I will delete it. I think I missed one. I should remove this. Okay, this is correct. This is correct. No, this is wrong. I have to fix like this. Here, this is correct. So I fixed like this. Now I will remove it too. And here it should be function. I have to remove this. 1, 2, and here 2, 1, 2. No, I don't need this. Fixed. Then here fixed. Okay, so I fixed like this. This is our final result. I will remove it. This is our quick sort algorithm optimized. Most optimized sequential quick sort algorithm. In the next episode, we will turn this quick sort algorithm into parallel algorithm. We will modify this part in my next episode into parallel algorithm. Now let's try if this function this quicksort algorithm is working properly. To follow this episode, you probably have to visit this extension library folder, C++ library extension website, and download this library and watch this video for system environment settings variable. Then you can unzip this file and you can open the folder. Now let's start with our Visual Studio Code. If you unzip this folder, you can find extension CPP extension folder. In this folder, select the tutorial and click this button, O17 Quick Sort CPP, Control V. Here include talk play fun output HPP. Okay, now we will copy this code. I will copy from here. I copied it and pasted it here. We will create a function void test sequential quick sort. Okay, now let's try. Here I will copy this sample, I copied and pasted it here. I will create stream, talk, play, fun, access stream, auto, and there, talk, play, fun, and there. Okay, now we call this function. It should be std vector. Then here, sorry, we have to remove t, stream, before sort, container, and L. Now we sort stream after sort. This program name is Quicksort. I will modify it into sequential, and copy this. We also have to modify here. Where is it? We also have to modify this. Okay. Then here, container, and now we create a function main. We call this function. Copy, paste. I expect some error. Let's try it. Start your command prompt. cl ehsc std C++17. We will optimize it. O2 O17 quick sort cpp fe aexe. Hit enter. Okay, it compiled successfully. cls a. Something wrong. It failed. Let's see what's the problem. Sorry, I made a mistake here. If container is empty, then we have to return just like this, or we can just return container. Okay, I missed this, so I will fix like this. Then let's try once again. Okay, it works. This is before sort, this is after sort. So I will copy this part, copy, and I will fix in our description. Please don't forget here this line of code. Okay, also we have to fix this. Okay, also we have to fix like this. Also we have to fix like this. Don't forget this part. Now everything seems to be working fine. I will try another function using string. I copy and paste. Now I say test sequential quicksort string. Okay, then I say std string and banana, then tango, then cherry, then echo, then apple, then fox, then EFGH golf, then hotel. Then let's see, A, B, C, D, D, E, F, G, H. I will replace like this. Now I think this is good enough. So I changed it to string. Okay, I modified it to string. Then we copy this, copied and paste it. I disable it. Now let's build once again. Okay, it works properly. Apple, banana, cherry, tango, echo, fox, golf, hotel. It's sorted properly. Now let's try with GNU compiler, G++, STD, C++17, O3 optimize, then O17, quick sort, CPP, hit enter. Sorry, it should be like this. Hit enter. Okay, it works successfully. Now with clang, hit enter. It also works successfully. So we learned quicksort in sequential quicksort. In next episode, we will turn it into parallel sort. Please subscribe to my YouTube channel. Thank you for watching.